We can start. Thanks everybody for coming. I know 8 in the morning and Vegas are, a tough combination at best. So this session is about service interfaces for the most part, as its essence. As services become more and more popular and they are more available out there and they tackle more and more problem spaces out there, so the infrastructure of services keeps growing and new challenges start to come up just because of the fact that they're becoming mainline, or they have become mainline already. The fact that we have more and more of these different services out there created by different parts of companies, by different companies altogether, and also by the fact that services are building blocks for bigger pictures, and we need to enable systems developers, infrastructures for developers, and so on, to be able to go build those value-add end-to-end solutions based on infrastructure services. It is a new space, so we are exploring how to tackle the problem space, how to make it easier, how to make it more effective to build whole solutions out of services that form the infrastructure of the applications you're building. My name is Paulo Castro. I'm the architect of the Project Astoria part of this problem space, which is sort of the framework side of things. But this is what we're going to go through today is a broader space. It spans application frameworks, development frameworks, services, and service interfaces. Specifically, we're going to drill down on how we are looking at Atom and Atom Pub, the Atom Publishing Protocol, as a way of unifying interfaces for service access on data-centric scenarios. We see that there is a growing number of services, and a lot of those services share common characteristics. And the question is, how do we make it more uniform to interact with all of those services, while at the same time staying on the industry standard side of things, trying to not invent new things that have to carry a lot of sort of surrounding technology to enable the scenario. What we are sharing today is our early thoughts. We want to be very transparent about how we approach this problem, because interfaces to services are something that we're going to have to deal with them for a long time. So we want to be open about our perspective right now, about what we're thinking should be the right thing to do. We're going to be showing real services that you can access right after this. They are the first CTPs of the new services with the new interfaces that we think are the right direction in this space. We're looking for feedback. So your thoughts in this space will be very, very appreciated. So let's drill down on the details. That is, if I actually can, there. So I wanted to briefly spend or go through how do we see service interfaces and characterize a little bit the different service interfaces. Then I wanted to talk about Atom and Atom Pub to make sure that we have the same perspective on the protocol and the format, and then drill down on Atom-enabled data services and what do they look like in Windows Live Services. And I'm going to sort of pick a particular scenario and go through a bunch of detail to see how to interact with a Windows Live Service for real, how to obtain data, modify data in the service, how is authentication and authorization integrated with this system, and so on. Finally, I'll talk about application frameworks, or development frameworks rather, and how do they play in this space. So if you look at service interfaces, there are many ways of slicing the problem, but there is one that is interesting with the problem at hand, which is the nature of the service. Some of the services out there are very operation-centric, just naturally. If you think about things like Messenger or Live ID, what you do when you talk to one of these services, or what the UI that we have for, say, Messenger does when it talks to its backend, is very operation-centric. It says, send a message, establish a video conference call. Or in the case of Live ID, you go and make literally a function call that says, here's a bunch of credentials, give me back a token that I can use later on for something else, for authorization purposes. So in general, these services are very, very centered around the set of operations that make sense for a particular service. And one interest characteristic of that is that the actual operations are of a specific nature of the service and are not generally understood by everybody. That's the point of the service, that operations are very specific to the problem domain. And so there is plenty of technology for this space. It's a very mature space. Things like SOAP web services, or even more informal interfaces where you just simply have a URL and maybe you post to it with some arguments, work pretty well. And since semantics on what the actual operations mean are not generic, I think we are in a good spot, and it's kind of tricky to push it too much further than where we are. On the other hand, there is another class of services that has more to do with the data than with the operations. Or better put, the operations on all of the sort of units of information on those services are very uniform. They look a lot alike. What changes is the nature of the data that you're exposing, how it is organized, how it links to each other, what is the structure of each unit of information, and so on. If you look at Spaces photos, or to even SQL Server data services that we announced this week, or many of these other services that are mostly about data, and operations are something that support the data, but they're not the center of the service. When you talk to, say, Windows Live Spaces to exchange pictures or to exchange blog entries or so on, what you do is operations on the data. You retrieve a picture, or you create a new one, or you maybe create a folder so then you can put pictures under or inside that folder. So what you're doing is operations that are very uniform. You create things, retrieve things, maybe modify things, maybe delete things. That uniform interface gives an opportunity to create protocols, interaction models in general, and frameworks on both ends that rely on the fact that the operations and the interaction model in general on these services is very uniform across the whole spectrum. What changes is the actual nature of the data. To the point that if you look at these services and you want to describe one of them, typically what you do is you don't describe the operations so much because they are a given. What you tend to do is you describe the shape of the thing. You say maybe photos is, you have folders, and folders inside have pictures or another folder or something like that. Or services like application-based storage, I'll touch on this later, but which is a way of storing sort of little bits of application-specific data out there in the cloud and making them sort of compartmentalized for each user and for each application. So every user has a way of having information stored in the cloud, and they have the way of them controlling that information, who has access to, and so on. All of these things are, again, very uniform from the interaction model perspective, and what they have in difference is the structure of the data. Those service interfaces, or those services in general, those that are data-centric, are the ones that we think are great candidates for the Atom protocol, for the Atom format and the Atom publishing protocol in general. And those are the ones that we're going to be focused on for the duration of this talk. So stepping back for a second and to try to tie up various pieces that we've been talking about this week, we mentioned, maybe some of you were there when we announced SQL Server data services. SQL Server data services is an example of an infrastructure technology or an infrastructure service. It's not a consumer thing, definitely. You need an application to use it. And what you do with it is, it forms one of the tiers of your system, in this case, the storage tier. You can think of that as an infrastructure service, and you can expect others to come. On the other side of the spectrum, but still on the service space, there is a number of consumer services that you can think of Windows Live Spaces, and we have many other consumer services out there that right now don't have an Atom Pub interface, but that they are also services and they are consumer oriented, like contacts or any other of the live services out there. Both of those are actually services that are hosted out there in the cloud. Then there is the third space, which is on-premises services. As organizations grow and work on decoupling systems to have better independence and better abilities to rev the systems independent from one another, and at the same time they want to be effective at sharing information, services inside the organization can borrow a lot from services out there on the web, both from the perspective of effective data sharing while at the same time maintaining very low coupling between systems, and also from the sort of scale out and effectiveness on growing perspective. What we want to do is, there is an opportunity here for all of these services on the data-centric side of things to be exposed through a uniform interface. And once we have a uniform interface over all of them, we can work on a single set of tools that span from Visual Studio to libraries for .NET and Silverlight to integration with our existing tooling frameworks like ASP.NET and Ajax, all the way to third-party components out there that can also pick up the same uniform interface and make it really effective, really straightforward to build real-world solutions on top of the services instead of having to focus on how to deal with the service itself, which is, in the end, not what the problem you're trying to solve. That's just something getting in the way between you and being done with the problem you're tackling. Since all of these scenarios are around data-centric interfaces to service, we are putting AtomPub, the Atom Publishing Protocol, across all of them, and we are using them as a unifying interface. Whether or not you look at the details of the protocol depends on your choice on tools and your requirements. Sometimes you will use our highest level tools that make the protocol pretty much disappear, although we just use it under the covers. So you don't sacrifice anything from the sort of interoperability perspective and so on, but you just don't have to learn it. And on the other end of the spectrum, you may actually care very much about the details of the wire format and the protocol in general, and you may actually be working directly with AtomPub and the Atom syndication format. So with this picture in mind, let me recap a little bit on Atom. How many of you are familiar with Atom? Okay, a lot. Great. So the short story, I'm not going to go through every angular bracket. That's a long and boring thing to do. There is an RFC out there you can read. So the Atom syndication format is, well, it's very popular as a syndication format. A lot of blog software out there can serve sort of the blogs as an Atom feed. But more in general, it's a general purpose XML format for sharing data. Not every piece of information is a good candidate for Atom, but it does cover a very broad space. In general, if you have things that can be structured as a list of things with units inside, and you have a reasonable representation for the content of each unit, then Atom is a very interesting candidate. And also Atom has, in the organization, it has these list things called feeds. And feeds are literally a sequence of entries. And entries can have links that can link to other entries or to arbitrary endpoints out there on the web. So this is a very nice, very general model. Like you can see from the description that there is nothing too specific about feeds on them. It is actually a more general model to say, if my underlying data can be expressed in terms of entries or records, or call them whatever you want, like units of information, grouped together in feeds, and then linked to each other using links, then Atom is probably a good candidate for representing that on the wire. The other very nice thing about Atom is that it's designed so it's very easy to extend both the data and the metadata space of the format. So Atom defines some basic elements. So you can see the example here where a field has things like a title and a last updated element and an author, and also has a set of entries. And the entry also has like title and updated and so on. And then it has content. And content is where the stuff is, like the actual data that you're typically interested in. Now, you can extend the format in a number of ways. You can add metadata elements to the feed or to the entries, for example, by simply adding an XML namespace and then having custom elements. And you can customize what the data is. The content element can have a MIME type that you can indicate. And then inside the element, you can have any nature of information, as long as, if you're using XML, you typically use a different namespace for it. But it allows you to have data of the nature that is appropriate for your particular needs. It also has the means to express media-centric information, and I'll get back to this in a minute. So Atom is a format, meaning it's a syntax to describe representations of items or entries or whatever you want to call them. Now, whenever you have a service interface, the format is one piece of a bigger equation. You have to actually describe what is the interaction model between agents using this protocol. For that, there is a protocol called the Atom Publishing Protocol, or AtomPub, that it became a recommendation, an RFC, not long ago. I think it was late last year. It defines, so it builds on top of Atom, and it defines the actual interaction model between clients and servers that are using the Atom format. So the idea is that by following this protocol, you have a simple framework for publishing and editing and deleting and so on resources out there on the web. And we use the word resources in the most general sense. AtomPub is essentially an HTTP-based protocol, which means there is very little invention, which is a feature for these things. By being on top of HTTP, you get to leverage caching, authentication, semantics of HTTP methods are there. So put means what you would expect, and post means what you would expect, and so on. They follow to use a fancy word or a fashionable word at least, they follow a REST interface or a RESTful interface. Just meaning that there is no heavy state held by the service, and the overall model is you use URLs to address elements on a server, and if you use the standard methods, the standard HTTP methods on those URLs, you get the semantics that you would expect from those URLs, and there is no sort of second-order semantics to these things, which means that even an intermediary sitting between clients and servers, for example, can know what some certain operation mean. For example, if you say get and pass a URL, everybody down the chain knows that you're retrieving a resource with that URL. So, for example, the caching, intermediate caching systems can kick in and do the right thing without knowing too much about your particular system. Similarly, when you say post, in this context, typically that means create a new item on the URL that points to the containing collection, typically a feed. And put similarly means replace an item on the server. And all of these things are known to the intermediate systems, if there is any there, which means everybody understands the semantics of the actions that are going on. And this is a very powerful concept. And actually, that's what keeps the web working, right? This is nothing new. It's just that we're trying to leverage it, and we're trying to stay on the do not invent anything side. And I think that's why the Atom Publishing Protocol and the group that created it did a very good job at sort of staying on the standards side of things. And I think that's part of the reason why it is being increasingly adopted out there. Okay, so we have Atom syndication format, great representation for exchanging data, and the Atom publishing protocol that defines how the interaction model works out. So let's, so far this has been kind of abstract, so I want to use a particular example of a service to drill down on the details of what these things look like and sort of make it very concrete so that then you can, based on this, you can just go ahead, try the services yourself, and give us feedback on them. So to drill down on a service, I'm going to use the Windows Live Spaces Photos service. This is one of the first services that we're rolling with a experimental or a CTP Atom interface. And we have a new endpoint. The endpoint is out there. I'll explain exactly how to use it and what it means, the ID thingy out there. But the idea is, so we have endpoints out there that expose the same data that you can actually access through the sort of Windows Live Spaces user interface, but it's exposed using the Atom syndication format and the Atom publishing protocol. Of course, one of the sensitive aspects of this is who gets to see that? Like, can you really just open an HTTP, like open a socket, send an HTTP request to this guy and get somebody's pictures or something? Obviously not. So enabling these services where you give access to especially to consumer services out there, but in general to services out there, brings a set of challenges around authentication and mostly authorization in general. So I'm not going to drill a lot into the details of the authorization model, but I do want to sort of go through enough to, for the rest of the context to make sense. So the one problem I want to highlight is, you know, when you go to some of the sites out there that do, for example, they have to do something to do with contacts or with photos, like a family sort of collective photos thing. One of the things they have to do is, if they want to collect your sort of your contacts or your pictures or whatever, they end up asking for your credentials because they want to go in turn and go to that server and pull the data. They may be very nice guys and all, but they want your credentials. That's a big deal. You don't want to give them your credentials. So that's a whole problem space that needs to be addressed. And we recently introduced Windows Live Delegated Authentication. It's been there for a while. We announced the 1.08 version of the SDK recently that tackles this problem space where you can say, I'm going to create a service that exposes data coming from somewhere else. And instead of having to go ask for the credentials, I can have the user go to a well-known trusted endpoint, in this case on the Windows Live side of things, and grant to a particular site the access or delegate access for a particular set of resources, and also for a specific set of operations. And once I have that, what I get is an opaque token, no credentials, that I can use to access the information on the user's behalf. Not only that way you don't share credentials, but also the user is in control of the information. You can choose for how long you want to share that information. You can revoke. You can go to a website without the intervention of the third-party application, and you can revoke the permission to access that information, and so on. So what does this service do? Like, I'll get back to authentication in a second, but fine, you survived the live ID dance, and now you want to actually do something with it. So it does what you would expect. It allows you to browse the contents of your folders collection in Windows Live, and you can create folders, create pictures, you can retrieve pictures, and so on. So let's play with this a little bit and look at it in the context of the Atom interface. Let me log in here, switch to my demo computer. So I'll get to sample code later on in the presentation, but what I wanted to start with was I wanted to show the actual payload formats and go a little bit through how we are using Atom and how do we leverage the standard constructs in Atom to represent information, in this case about pictures. This little thing is just a test harness that I use to interact with the system. Since this is plain HTTP, it's actually all I need is the browser. The only reason why I have a different Chrome around the browser is because I need to send credentials and stuff like that. But other than that, this is just HTTP GET, and the response is just plain XML. So I'm going to log in here. Hopefully I'll get that right. I did. So I showed the URL before. URLs for these services are formed of a prefix, that is the host name, the entry point to the service. Then there is an ID. The ID is, it can be a couple of things. In this case, it's going to be my username. Most typically, you will do this in a web application where you don't even have the email of the user and you don't want to use it in this context. So what you usually do is use a CID, which is a number you get out of the exchange of tokens between the authorization service and the third-party service. And I'll show a concrete example of that in a second. And then we have to say which service we want to talk to. In this case, this is going to be Atom Spaces Photos. And within Photos, what do you want? So in this case, I'll go to a root collection, which is the folders collection. So I'm going to do a get here. And I get a bunch of goo back, and I'll get back to the details in a second. Now, to put this in perspective and to parse this information, what I want to do is I want to go to my Windows Live Spaces account. And what I'll do is I'll have my service and my XML stuff side by side so we can compare what it means. So what I have here is I have a couple of albums. I have an Astoria Design Meeting album and a Green Design Meeting album. And inside each one of them, I have a bunch of pictures. So if I switch back to my application, what I have here is a feed, because we said like the way we represent sets of things in Atom is by using a feed. And the feed has some feed-level metadata. And also it has a set of entries. So in this case, I have two entries that correspond to the two albums. Let me expand one of the entries. So in an entry, I have like a category that sort of classifies the nature of this entry. I have publishers. I have a title that says what the thing is, what is the standard name for this. And there is content. In this case, a folder is not much more than its name. So the only extra piece of information that we have here is an ID that I'm going to use in a second, and you'll see why it's interesting to have one. A couple of other things to notice around the payload is, as part of the Atom pub spec, there is a special kind of link element in the Atom entries that is called the edit link. The edit link means this is the URL that you go to when you want to go make operations on top of this resource. For example, if I wanted to modify something, I would go do an HTTP put in this URL. What I can do is actually I can do a get of that guy. And if you look at the URL, this is actually the same URL I have so far here, except that it ends on folders, and this is wrapped around, but this 144 number here is right at the end of this. So the URL looks like this. If I go get this guy, what I get is just the entry. So sometimes if you do a get on a set of things, you get a feed. And sometimes you do a get on something that is a singleton, and then you don't get the feed around it. You get the entry itself. The entry is identical to the one I just looked at. And the other thing that you can observe here is, so there are some links, like the edit link, that are predefined. And then there are links that have to do with the nature of the schema. In this case, a folder contains a collection of photo entries. So there is a link here that says there is a bunch of related items. And the type of the feed, or the type of the target of the link is actually an Atom feed. It could be an Atom entry if the link or related thing was a singleton. And the title of this thing is photos. And more importantly, the link to it is the link to where we are now, /photos. So let's go check that out. So if I go /photos here, what I get is a feed again, because now this is photos in a particular folder is a collection. And if I collapse the entries, I can see that there are 3 pictures here, and if I open one of them, I can see the title of the picture and a bunch of links, and I'll explain some of them later, and whatever information is interesting for that particular picture. Now, an interesting thing to highlight is, so far I talked about the structured data. Like when we talked about a folder, for example, we said we only have the ID, but we could have a bunch of information there in the form of structured elements. Now, life doesn't end with the structured elements. A lot of the data out there is unstructured or semi-structured data, and pictures is a perfect example of something that is more like a blob, and you don't want to inline that information in an Atom entry. So Atom has support for what's called media link entries, that allows you to have content out of band and just pointed at by the content element instead of inlined. In this example, if I go here, there is a content element just like before, except that the type of the content in this case is a JPEG. So this is the MIME type for JPEG. And the content element has a, excuse me, has a source attribute that has the URL to the actual element. This element is the actual picture. And which in this case, I'll formalize the syntax in a second. For now, I'll just copy paste the URL. And if I do a get, what I should get is the picture back. And this is a nice design meeting outside when it was summer back in Redmond. All right. So coming back here, the idea is you can use the URLs that I just went through, and I'll come back to the details in a second, to browse information. Also, just like I could retrieve an entry, you can create a folder or a folder or a photo or whatever by simply creating one of these payloads and doing an HTTP post to one of these endpoints, or an HTTP put or a delete for each one of the operations. Some of them are as simple as, say, you want to change metadata. You simply form the new payload and do a put, and that would replace the structure on the server. Same thing with post for things like folders, for example. You will form the payload and post it to a root. Others need a little bit of a two-step thing, or at least a slightly variation of the interaction model, particularly when there is media involved, or something that is not structured data. Typically, what you do there is you actually post just the media, not the structure, because you don't want to mix the two. You have to, like, base64 encode it or something like that. So for media link entries, typically what you do is you just post the actual picture or whatever you're posting document, and there is a header defined by AtomPub that allows you to give it a title or some form of identification to get back to it later on. Then you can modify the rest of the metadata properties afterwards. Now, here. So I sort of hand-waved over what the URLs look like. Typically, most of the RESTful interfaces try to stay away from defining URL formats or strict syntaxes and so on. And typically, it's a good thing. When you want to create a very general purpose infrastructure or protocol, or in general, a model to interact with services, you want to avoid over-constraining your specification. Now, once you narrow it down to a particular problem space, the opposite starts to happen. It becomes very interesting to have a uniform pattern that is predictable across any of these services. That way, not only you can type URLs in your program or in a user interface or something, which I'm sure that people here will do, but that's not the typical user endpoint for these services. But also, there is the opportunity of building tools and developer frameworks that leverage that information and make it easier to interact with these services. So let me formalize a little bit what the URL format looks like and what it means in practice. Let me switch back to my demo machine. So the idea is every service has a service root, which in this case is photos. It's just like that without the slash folders. And the root itself may contain a resource like underneath it or not. In this particular case, this service does not contain a resource. So if you do a get here, you get a 404 or 403 actually. And underneath there is what is at the top level is the collection of top-level containers or collections. Sometimes you have a single collection, like in the case of folders. Sometimes you may have more than one collection out there. In this case, I have one collection. So the first thing you say when you say /folder is you're choosing a collection name. And if you do a get on that, what you get is all of the contents of that collection. Of course, if the collection is very, very large, then you have to work around that. Typically, what happens is, in these scenarios, so the Atom syndication format defines like a number of paging constructs where you can say, here are some of the entries, but they're not all of them, and here's a link to the next page of entries. So by looking at one payload, you can scan it, and then there is a link to the next set of entries, and you can keep chaining. So whenever you have a collection, in what we do as a convention, and again, so Atom or AtomPub don't say anything about URLs, so this is a convention we adopt to make all of the service interfaces be very uniform, is we go like collections of things. Usually, if you want to be able to point to one of them, there has to be something that uniquely distinguishes one from the other in all of the items within a single collection. So in our case, we give things IDs. Like in this case, this is the ID of this guy. What that means is, given any container, you can, in parentheses, put the ID value, which in this case is a number, but it could be a string, or it could be a compound value, and so on. And when you do that, and you do a get, what you obtain is a singleton that represents that particular resource, and in this case, in the Atom representation. These URLs, in particular the ones that point to singletons, are read-write, meaning you can do a get and you retrieve it, and you can do a put, and that means overwrite the values there with the ones I'm sending. You can also do an HTTP delete, which means sort of delete the resource. It's not always the case that all of our operations make sense on all of the resources. For example, a post to this URL would fail because usually the way we look at post is, which I think is pretty much the standard assumption, is you do post to a containing element, a collection or something, but to mean post and add this item to the collection. So usually we allow posts at the feed level or the collection level, but not at the element level. So to continue with the URL format, once you are on an entry from the URL addressing perspective, you can keep drilling down. And there are a couple of things you can do. One thing you can do is you can address simple members. Like in the case of folders, you can say title. And what that gives you is only the title, with a bunch of markup goo around it, but it's only the title. In this case, this is like green design meeting. And if we go to the previous one, I think we had another one. Of course, I don't know the number. Let's go back here. Actually, let me go to the folder level. So the second entry was 128. And if we go to this guy and say /title, we will get a Astoria design meeting. Also, like once you get to the element level, like the scalar value level, oftentimes you actually don't want the markup go around it. You just want the value. So we have a special operator that you can put at the end, a special resource, that says, I'm addressing this thing, but what I want is a raw value underneath. I don't want the rest of the stuff, which is actually very common in practice to need. So this is a simple way of obtaining that, and I'll get back to why this is interesting in a second. So popping back up, this guy, title in this case, is the name of one of the elements of this entry. If you look at the entry itself, let me do a get here. The entry has elements that are, I'm going to call it scalars, like the title or the ID or things like that. And there are also elements that are links. In this case, there is one link, which is the photos collection. So in the end, whenever you say /, what you're saying is, I want to access that member. If it is a scalar, you get the scalar value. If it is a link, you get the result of traversing the link. So you get whatever is sitting at the other end, which can be a scalar or it can be a set. So when before I said /photos, what that meant is grab the entry folders 1 to 8, and from that, go to the photos link and deref that. And this is very uniform. This keeps going as you navigate the space of resources. And the same with a different schema would work exactly the same. It's just the names of the things would change, but the actual structure of the URLs and the meaning of the different pieces will remain the same. Let me give you one more quick example. If I scroll down to the photos collection, I can see that there are a number of photos, so I can pick one, say 143. And again, I can keep nesting. Now, this is pointing to a particular picture, and that's why I get an entry. And in general, in Atom, things tend to be flat. But in this case, we have a clear sort of, there is a collection of folders, and folders have a collection of photos, and photos has a collection that you can see here of what we call image streams. So you can get a web-ready picture, or a thumbnail, or a high-res picture, and so on. So we represent that by using nested collections that have links between them. So we said before you can say /title or something like that, and then say /$value, and that means give me the raw value. When you have a media link entry, like a photo, the entry itself has a value, because in the end, this represents a piece of media, a document or a picture or so on. And coming back to what I used before, that's why $value makes sense at the photo level. When I retrieve that, I'm retrieving the raw value of the whole thing, which in this case is a picture. And this is just another design meeting picture. Similarly, I can keep going down here. I can say image streams and keep drilling down. In addition to the data browsing structure of the URL that allows you to point to particular resources in the resource space, we also have a few other constructs in the URL. One of them, which is still like resource-like, is a way of retrieving metadata. Like, how do I know that there is a folder staying here and a photo staying here? Well, one option, if I'm writing a program that is specific for, say, photos, is I just know about it, and that's a perfectly fine thing. Now, you may want to generalize this a little bit. What if you want to write a development tool or a framework or a browser of any service type of thing? Well, you want a description. Problem is, how do you describe one of these services? Clearly, describing the operations is not very interesting because we already know them. So what we have to describe is the shapes of the things that are sitting in that service. In the end, like from what we saw so far, a service of this kind is a set of collections with a set of things on those collections that are also linked to each other. So what we need is a structural description of the service. Now, all of these services have a special resource. You'll see $signs all over the place. Usually $sign means our namespace, no $signs, your namespace. So that way we avoid name clashes. So there is a metadata endpoint. And when you get that resource, you get a bunch of XML stuff. And for the most part, people don't have to parse these things. But let me just scan through this real quick. I'm going to collapse this first. So what we're describing here is a structure space where there are what we call entity types. Entity types describe resources in terms of an entity model. We use an entity relationship model because it maps very naturally. In the end, we are talking about resources with links. And this model uses entities and associations. We map one-to-one between constructs. So an entity type has a structure and it has a key. The key allows us to address any one entity in the system. And the properties are the properties that make make up the data that is carried by this particular resource. You can also see that there are navigation properties, and these are the ones that form links between things that we've been using so far. So for a folder, this is the photos collection for that folder, and this defines the link between folders and photos. This is expressed in terms of the entity data model, which is also used extensively by other tools in our middle tier space and as well as our web-based data sharing technologies. So let me go back and close on the URL format details. A few other options in the format. So for those of you that are familiar, how many of you know what Astoria is? Wow, okay. So Astoria is, I'll get back to it in a second, but it's a framework to create these services when you want to create on your own, and also to consume these services across the board. So one thing we did is we unified the URLs on our infrastructure and consumer services, and the ones that Astoria uses when you create third-party services, so that we can use the same tooling and same clients across all of them. So for those of you that know Astoria, you'll find these URLs familiar because they're the same. Like, we designed these things together. So a few options that are supported by some Astoria services but not others are what we call the presentation control options. Things like, you may, given a collection, for example, you may want to say what is the order in which you want that collection. Or you may want to request a subset of the items by using paging operators like skip and take. And you may want to filter stuff too. You may want to say, well, so this is a big collection, give me only the current items, or the items after this date, or the items that satisfy certain expression. The services that we're making available for the first time today don't support these options yet. But as they make sense for a particular scenario, we can consider which options we will introduce. The important thing is, if a given service supports one of these presentation options, they will look the same across all of them. So we can rely on sort of uniform interface and uniform semantics around them. Of course, the service world is it's very broad, very different requirements, very different characteristics on the services. So we don't expect perfect sort of single interface across the board. It's very unlikely that that happens. So we're trying to be flexible about this. All we're saying is, if you do certain things, just do it the same way. But you're not forced to have exactly the same capabilities across all services. And finally, there is the metadata aspect that I mentioned before to retrieve the metadata document. And that can be used by tools and things like that to produce maybe client-side proxies or UI representations and such. OK, so we have these Atom services now. How do we talk to them? How do we interact with these services as developers? You want to go write an application now, and that application needs to access, just to follow the example, needs to access the pictures collection from my Windows Live account. So how do we do that? Well, first of all, we didn't invent anything here. So this is just HTTP. You do an HTTP GET. You get an XML representation of the resource. You can just parse it, just using an XML parser, which sets the bar pretty low. Of course, you have to still go through the proper authentication and authorization scheme to get to the resource. Otherwise, you'll just not get through the interface. But once you go through that process, and we have SDKs that show how to do authentication in a number of scenarios and environments, then any HTTP stack should be enough for an entry-level experience with the service. Of course, nobody likes pain. So the more we can do to make this easier and push the level of abstraction you operate on up, then the better for the general consumption of services. So there are a number of AtomPub libraries out there already available that you can use to deal with Atom feeds and entries, like at the format level, and also with AtomPub in general. These libraries are available for different languages and different operating systems and so on. To pick on one example, in the .NET framework, we have a set of classes in what we call the Windows Communication Foundation, which is our toolkit for anything that is distributed systems related. There is a set of classes, we call them the syndication classes. And these represent, in general, feeds and items in Atom or RSS feed formats. So that's an example of an easy way to interact with these services without having to go all the way to having to parse the XML and understand what a link means and a title means and so on. Let me show you an example of that. I'm going to minimize this guy now. So what I have here is, somewhere here, a very simple, like almost an empty web application. All I did was I added a few references, so you don't have to wait for me to go find the right DLL and all that stuff. So empty page, empty code. Let me explain this first. So in general, when you're a website in particular, so there are three players here. There is the user. There is the site that has the resources, in this case, Windows Live Spaces. And then there is the third-party site, which is what I'm building right now. So there are two things. First, you don't want to give the third-party site the credentials, as we said before. And second, you want to establish a way for the user to control access to those credentials. So the way this works with Live ID is there is a Windows Live ID delegated authentication SDK that you can go download from the web. There is a link at the end of the presentation. And once you have that set up, you'll see how your site can redirect to this third-party, or in this case, third-party from your perspective is Microsoft site, to set up consent for a particular set of resources. So the user goes there, gives consent for, say, in this case, Windows Live Photos. I already did that. And says, I can read only or read write and so on. Once you do that, the site comes back to your website and gives you what is called a consent token. Part of that is a delegation token. Delegation token is just a bunch of letters and numbers that you don't need to understand. It's this guy here. And it's what you use when you want to go back and connect to that server. If you get the wrong one, you'll not get authorized, so you're not going to get anything. And if the user goes and revokes consent, revokes access, because they don't trust you anymore, or they don't want leftover things that have access to their accounts, then simply next time you try to use the token, you're going to get an unauthorized response. The idea with the tokens is, like here I'm building a single user application, so I know mine. But the idea in general is by your own means, you establish the identity of the user, either with your own authentication scheme, or you can use the Live ID web SDK to use Live ID integrated authentication. And now, once you know who the user is, you can go to your database and look up the token. You're supposed to store this token somewhere. And if it is expired, you'll go refresh it. And then you can use the token for the rest of the application. In this case, this is a single user application, and I don't want to go through the whole process. So what I did is I hard-coded my particular token. And I need to finish this demo today because probably tomorrow the token is not going to be good anymore. I will have to go refresh it. So what I have here, lastly, is the actual URL to my service. And before I said that the thing that goes here is an ID, and I used my email address. When you use certain kinds of authentication, you can use your email address there. In the scenarios where you do delegated authentication, the other piece of information that you get back is this obscure token called a seed, and that's what goes here. And basically, that establishes an namespace. What hangs off of this, like on the rest of the URL, belongs to the user identified by this big number. Okay, so let's go build a little access path to our photo service from this website. So we're going to start with folders. So let's say that, let me switch this to design mode. Let's say we want to be able to pick a folder from the collection. So I'm going to go folders, and then I'll go here, grab like a combo box, drop down list, and we'll make it a little bit bigger. And what I want to do is, when the page is loading for the first time, I want to go fetch the collection, the list of folders, and put the list of folders in my combo box. So fairly straightforward. So what I'll do here is I'm going to use a regular Atom Pub client, which is or Atom client, which is the syndication classes. So I'll say if not is postback, meaning it's the first time I'm hitting this page, then load folders. And now let's implement load folders. So what do we want here? We have to do an HTTP GET to a server. So we're going to use a web client. Web client C equals new web client. Now, we cannot just do a GET. We just talked 15 minutes about authentication. Or authorization. We have to say who we are and why we can access this thing. So I'm going to use a token that lets me access on behalf of the user, which happens to be my account. So what I'll do is I'll set a header called authorization. And you'll typically never do this by hand. I'm doing this by hand the first time, so you see the whole thing under the covers. So the actual authorization header is what we call a delegated token. And the value of the token is, I'm going to open quote, and then put the delegated token that I already have, and close quotes. Okay, now I have an authorization header in place. That means the system will let me through. Now what I need to do is I need to do a GET, and then put the response into my Atom classes. So the response of this thing is a stream, so I'll say using a stream s equals my web client.openRead, and here goes the URL. The URL in this case is the service with the ID here. So let's go here and say string.format service CID. Okay. So now we have a stream, we can parse this thing. So I'm going to create a feed object because I know that the URL I'm going to use returns a feed. In particular, I actually didn't set up the URL here. So this is the root of the service. Now, what do we want? We want /folders. So I'm going to say /folders. I create a feed, and this feed is syndication feed.load. And what do I load? Well, I create a new reader off of my stream. Create s. Now that I have a feed, I can just scan the entries in that feed and extract, in this case, the title to put it in the combo box. So I'm going to go for each syndication item in feed.items. And for each one of them, I want to add something to the combo box. So I'll go drop down list1.items.add item.title, which is a standard member of an Atom entry. So I have a strongly typed accessor for it, .text. Okay, so we created a client, set up the headers for authorization, and then did an HTTP GET, parse the response into a feed item, push it into the combo box. Let's run this thing and see if we missed any of the pieces. So what we get here is the folders, and then we have the two folders that we had before on the website. So pretty straightforward. It wasn't too painful. And the nice thing about this is there's nothing special about these classes. And this is what we're trying to highlight, is you get to choose how low or high level you want to go. You can just open a socket if you want. You can use these classes, which are similar things like these, are available for a very broad set of languages and frameworks and so on. And it makes it straightforward to interact with these services without knowing the details of how the Atom elements turn out, how they are organized, and so on. Of course, if you want to drill into more information, like in this example, let's say you want the ID of the folder, which is probably what you want for the value of each entry. You don't want the text, you want the ID. Then you have to go grab the content and parse it. And that becomes specific, of course, at that point, because, well, it's in the nature of the particular service you're interacting with. And so if you know the characteristic of the service, we can do better than that, and I'll get back to that in a second. So we just saw how using standard AtomPub libraries, you can very nicely, very easily interact with these services. Now, how do we take it one step further? As I mentioned before, we're working also on Astoria, which is the official name now is ADO.NET Data Services Framework, to make sure that the developer frameworks and the services work together on a unified interface. What that means is the investments that we're making on rich client solutions for the client stack will work against your on-premises services created with the data services framework, as well as with the consumer and infrastructure services out there on the web. So you learn one thing, you get used to one kind of protocol, one payload format, and if you want to use the framework for the client, one set of APIs on the client, and you can use them across a whole spectrum of services. So let me take 1 second to drill down on the services framework, and then I'll put together how this can be used against the particular service we've been using so far. So the data services framework, we announced it last year here at MIX, actually, as Project Astoria. It went really well back then, so we got strong feedback that we should turn this into a product, so we turned it into a product. And we're going to go beta very soon, a few weeks, and we're going to finish it also mid-next year, so you'll have those bits available very soon. The framework has two goals: to allow you to create services, data services, and to allow you to consume data services real easy. And for all of that, we use a model-driven approach where you define the shape of your service using the entity data model, the same metadata format you saw before. And then we produce a service head on top of that is fully Atom compliant. It has an AtomPub protocol endpoint, and it also supports other formats for other scenarios, like a JSON format for Ajax applications, for example. So how does this play with the services we've been talking so far? So we have a rich set of clients for all of these services. So regardless of whether you create the services with the data services framework or you're consuming Windows Live services or Microsoft infrastructure services, you can use the same tooling. And in this case, we know that we are using AtomPub under the covers, so we can make those assumptions. And we can go one step further. We understand the payload formats. We understand what links mean to us. We understand all of these details about the systems. And we also know how to get metadata off of these things. So without introducing any new constructs on the protocol or on the payload, we can still up even one more level of abstraction the developer experience and make it more natural to talk to these services. Let me illustrate this point in code. So this is great, and it's nice because it will work on any feed out there. Now, if I know the nature of the thing, I may want to go more specific. So let me do the following. I'm going to pin this here for a second. So one of the things we have is we have a set of tools. Right now it's a command line tool. We're looking at integrating with Visual Studio as well. That what you do is you point to one of these services. We fetch the metadata document that you saw before, and then we can code gen a set of client classes that represent each one of these entities on the server. Now the interesting thing is we've done this for years, right? Like we do this for web services today, for SOAP web services. Now for SOAP, what we do is we generate a bunch of operations. But here, there are no operations. What we have is structures. So what we do is we generate the types that define the shapes of the resources out there. Let me show you an example. I'm going to take here this and add it to my project. So when you run this tool, I'm not going to make you wait through the process, but just take a quick look. This thing gets auto-generated. So I get a type that represents the service as a whole. It's my endpoint to the service. And then I get a type for each one of the interesting constructs in the system. For example, this is my photo type. And you're not supposed to mess with this code because next time we regenerate it, we're going to override your changes. So we generate partial classes for everything, allowing for customization. Again, we don't expect services to be all identical. That doesn't happen, right? If anything else, different versioning speeds and different requirements will push differences into this thing. So the client stack is very flexible on the customization side. In this example, I have a set of customizations in this other partial class, and this is my user class. So when I regenerate my my code off of the metadata, this file does not get overwritten. So in this case, I wanted to add a new constructor so we can do the delegation stuff. And I added a new namespaces and a new event handlers because I wanted to tweak a few things as I go into a service and out from the service. So this is a very flexible way of preserving your interaction model very uniform, but at the same time being able to tweak things under the covers to compensate for any difference between any one service and the next. So let me go here and add a namespace for spaces photos, which is the name of the schema in the EDM schema we saw before. And now here, let me re-implement this guy, this time using the data services framework client. So we auto-generate a representation for the service as a whole. This is service, so I'm going to go new. Oops, there. Service, I have a few constructors. So I created a custom one. Typically, we just take an ID, URL here. I created a custom one that takes all of the Windows Live specific things, like the URL, the seed, so we can format the string, and also the delegation token. So I'm going to pass the service, the seed, and the delegated token. There. It's great. Nobody move. Let's see if this comes back. There. So hold your breath for a second. Let's see how it goes. Yellow. There. Okay. Let's see how far we get. So delegation token. So this is the 3 arguments we've been using so far. It's just that by using the same extensibility mechanism, I encapsulated all that, so I do it once, and I don't have to deal with it again. Now, I want all of the folders, and for each folder, I want to add the name into the combo box. So I'm going to say for each folder, and I have a folder type now, because it comes with the metadata description, so we create a type for it, f, in service.folders. I know there is a /folder, top-level collection, so we may as well give you a strongly typed access to it. And for each one of them, what do we want to do? I want to do drop-down list1.items.add folder dot, and you can see the actual properties here are the properties of this particular guy. This is not a generic sort of entry. It's the shape of a particular folder in the photos service. And that's it. So I can get rid of all of this. So the nice thing about this is, since we know more, we can make you work a lot less. There is nothing here almost that has to do with infrastructure. This is precisely the behavior that you wanted to describe and nothing else. So let's see if it actually works. Let's come back here, hit refresh. This will go to the service again, authenticate again. And yeah, this is not very exciting, same output. But the point is, this time we got through the very easy high-level framework. Now, let's say I want so for every item, I actually we set the ID and the name. That was how we got here in the first place. So the items constructor, or the items collection in the drop-down can receive just a string name, or you can create a list item and pass here like the ID and the name. One of the interesting things about having everything strongly typed is that other technologies kick in. For example, I can use language-integrated query or link to deal with my objects. I can use link against my local objects, or I can use them against the server. So let me start with an example where I bring first everything down to the client, in this case the folders, because I know I want all of them, and then I use link in memory to transform the shape of what I'm using. So I'm going to write a query that says, from EF in service.folders, I'm going to say as enumerable, which forces the collection to be brought into the client and exposed as a sequence. And then here I'm going to say select new list item of, first argument is what is visible, so I'm going to say name, and second argument is ID, and this is an int, so I'm going to say toString. So in one statement, I can turn the set of folders into a set of list items ready to be inserted into a combo box. So next thing to do is I'll say drop down list1.items.add range, because I have a bunch of them, and I'll say query.toArray. So again, not very exciting. The output is going to be identical. The only difference is if you look at the HTML underneath, each one of these now is backed by a value that is the ID of the thing, and we'll use this in a second. And from the coding perspective, it's nice that you can pull a bunch of objects and then use link to transform the thing in memory. Of course, here transformation is trivial, but once you are in memory and you're using link, you can pretty much express anything you want here that fits into a link query. So we have a list of pictures, great. So, sorry, of folders. Like, folders are the most boring part of the service, right? You actually want to get the pictures. So let's work on that a little bit. What we want to do now is, whenever you choose an element from the combo box, we want to go and fetch a bunch of related objects. We have a folder, we want the items for that folder. So I'm going to tweak a property here, auto postback is true, and now let's go to the event. Oops. There. No, not that guy. Just double click it. There. So this event gets fired whenever you pick a new row in the combo box. So what I want to do here is go to the service and fetch the pictures for this particular folder. So I'm going to grab this same line from here and put it here. The service wrapper is completely stateless, as you would expect. So you can just create a new one in every interaction. They're very cheap. So there's no overhead on just creating a new one. So what do we need to do? First, we need to know the ID of the thing you just selected. So I'm going to say ID equals in.parse, drop down list 1 dot selected value. Now, next thing I need to do is, now I need to go retrieve all of the folders for this particular, all of the photos for this particular folder. There are a number of ways of doing this. In this case, what I'll do is I'll say service.create query. I want to create a general request to the service. And I know the return type. I know it's photos. So I'm going to tell that to the system. So when I get the responses back, I don't get generic things. I want photos. I have a photo object, and it has all the members. I want to use that. And the URL for this guy is folders. And then I'm going to use the ID, which I got from here. So I know the syntax, so I can just rely on that and put it here. And then here I'll say photos. So now that I know this, what I can do is I can just iterate over this and display them somehow. So let's come here real quick. We're going to grab a bullet list, nothing too fancy. Come back here and say bullet list 1.items. And then you have to add all of the items, right? So what we have to do is for each photo p in the query, items.add, oops, the title of the photo will be what we want to display in the UI. So again, very similar to the previous pattern, just that this time we used a URL or a relative URL to address the particular set we are interested in. Let's compile this and run it. At least after 15 minutes, you'll see a different screen. So if I choose here, say, Astoria design meeting, I should get all of the pictures. And if I go green design meeting, actually I should. So these are the ones here. Of course, I didn't clear the collection, so they keep piling up. Actually, let me just clear it here. .items.clear. So whenever we are working with this, we can see a difference. So this is great. It's just that so far we did all of this strongly typing thing. Even here, I justified how nice it is to do the strongly typing. And then I went ahead and opened quotes and concatenated a bunch of strings. You may want to actually use link also to query these remote things. So let me change this into something that uses link and leverages the fact that we have type information that describes the shape of the service. So I'm going to say, what do we want? So we want from f in service.folders, I want a particular folder. So I'm going to say f.id equals the ID that I have. And then from that, what I want is the photos. So I'm going to say from p in the folder I have .photos. So it has a photo collection. And we know that this is a link. So we can translate it appropriately. Select P. So if I compile this, let me do the following here. Instead of just running it, let me debug through it. I'll just hit F5 here. So you can see what's going on. This guy. And then I'm going to choose something. So we have the query formulated here. And of course, we don't want any funky proprietary thing under the covers. What we want is a nice programming model, but we want to preserve the standard interface. So the query here is very nice in the user interface. And if I hover over the query, what I get here is a little bit small. But what you can see here is the actual URL that got produced. So what we built is a translator that takes link queries and turns them into URLs. Of course, this is, the expressiveness of the queries that we take is bounded by how much we can express in the URLs. And we'll do what we can. And whenever we can't do something, we will be careful not to do too much magic. And instead, what we do is we simply fail, saying, hey, this request is not translatable to a URL. Maybe you can partition apart and do it against the server, and then bring the data and do the rest on the client. The one thing we don't want to do is magic, like automatically partition the query or something, because maybe you tweak a query a little bit and you go from bringing one entry to bringing all of them and then subsetting them on the client or something. So if I let this run, the output is identical to the previous one, but the code here now looks a lot more high level. So finally, let's change something. We've been displaying a lot of stuff, not changing anything. So let's create a folder first. We'll go real fast through this. So what I want to do now is I want to allow the user to create a new folder. So similar thing, we're going to say new folder, and we're going to drop in a text editor and a button. What I want to do is when you click the button, I want to create a new folder. So let's go here and say, I'm going to steal this guy. So what we want is a new folder. So I'm going to create a new folder object, new folder. What do we know about the folder? We know the title. So folder.name equals textbox1.text. And what we want to do is add it to the container. So we're going to say add object to the folders collection, F. And when I'm done, I can say save changes. I could have made several changes, piled them together, and then save changes at the end. And we will take care of saving the whole sequence. So let's try this out. I'm going to compile this, come here, hit the page again, and also I'm going to come back to my Windows Live space here and refresh this for a second, make sure that we have still 2 folders there. And we have 2. Now here, now we have this new folder thing. So I'm going to go call this the work session folder, click the button, and if I go back here and hit refresh, I see that I have a new folder here. And of course, similar to this, I can go create pictures and put the picture on the folders and so on. It's like essentially the same pattern. Now, we wrote a bunch of code so far. And typically, every application, you end up writing a bunch of code. But there is a lot of boilerplate code that it's easily automated, especially with regular tasks like grabbing a resource, editing it, and so on. So in addition to the raw support that we have here, we also have support for, in ASP.NET, data source controls that allows you to plug into the data binding framework. What that means, this is the last thing I'll do here, is you can come here. Actually, let me switch to design mode and show you this. You can create a data source object. So I'm going to go here and say data service data source, ID DS1, and I'm going to say run at server and allow async. This is the stuff that you got to say. And then what I want to do here is I want to say query path equals, and this is the URL I want to fetch, in this case, folders. And it's probably, last thing is I want to say, what is the client wrapper, the type that I want to use to learn about the details of the shapes of the objects, which so far we've been using these spaces, photos, dot, spaces, photos, service. Okay, so now that we have a data source, what I can do is I can come here. No, actually not there. Here. And bind controls to it. So let me drop a grid. Grid view. So grid views come with ASP.NET. They are well integrated into everything else. So I can, for example, format it, make it nice, make it bigger or something. And then in the data source, I can pick the data source I just created. So I'm not going to write any code for this. I can also enable options here, like just pin this so it stays put. Be nice to get some properties out of it. I'll just close and open the thing. And switch to design mode again. There. So I'm going to say generate a delete and edit buttons here. So finally, of course, I did a bunch of authentication stuff or authorization that I want to preserve here. So what I'll do here is I'll say ds1. Service root is the same service root we said before. So this is service and seed. And the actual data context object is a new of, actually, we can borrow this line from here. There. So now, if I compile this guy, and if it builds, it did. And let's refresh this page. So what I have is the list of folders I've created so far, which of course matches the one I have in my Windows Live account. Now, I didn't write any code to display this, which is already nice. And I actually have, like, since the interaction model is the same, not just for retrieval, but also for creation and modification, I don't need to say anything to explain how to perform these operations. For example, let's say this is not really a working session. This is a sort of ski session, which we did the other day. So I'm going to click update here. Again, didn't write any particular code, but it changed here. And if I go here and hit refresh, then this thing becomes the ski session. So like, this was literally no code on the server at all. Or the authentication dance you have to do once. But other than that, it's pretty much automatic. So to close on this whole sort of tools and framework thing, so far I talked about things we built. And we as Microsoft, we like our services a lot, so we'll build a lot of infrastructure for it. But there is an opportunity here for third parties as well. People that know how to build application frameworks or UI tools or components and so on, to build great tools that fit in naturally on this thing. And since this spans a lot of services, once you build them, there is an opportunity to sort of leverage the fact that many users out there will need these infrastructure components for different services. Let me give you an example. Our friends in Component One is a company that builds frameworks and UI components and tools. They've been working on some early prototypes of stuff for that integrates very nicely with Astoria, and that also works with any of the services that speaks the Atom protocol, and they can be used through the Astoria API. So they built a demo for us. I'm completely illiterate about WPF, so all I can do is like open the page, and then I can switch out the code, but the UI is, it's just magic for me. So they built a very nice UI. In this case, what I'll show is Windows applications against the same service, the photo service. Typically, so our standard terms of use do not allow you to build clients like this. They usually assume that you will build a website, but there are means to do this if you're interested in the space, and you can read that in the terms of use. So let me run this guy. Since I'm on the client, there is nothing to delegate. So what I'll do is I'm using the client Live ID SDK to log into my service. I'll put my password here if I get it right. Wrong password. There you go. So what this will do is it will go to the service, authenticate first, then go through a service and die trying. I give it one more shot, then I move on. Oh, come on. Let's give it one more shot. One more. Actually, I think I know what it changed. We'll give it 30 seconds, and then we'll just move to something else. Oops. That's okay. Let's do a F5. Maybe we caught what's going on. Anyway, I'll try to show it. Anyway, Mike Flasco has a talk at 11:30 or so, where he'll show a lot of these components running. So if you're interested in it, they're very slick once they actually make it. They're running and working. Of course, the moment I touch these things, usually they just die. There you go. At least we're going to know what's going on. Oh, I have the wrong URL or something. Okay, I'll show it. I promise I'll show it later for anybody that is interested. So it's slick UI components. It's actually very nice. Let me go back to this. And if I have a minute after the talk, I'll try to show it at the end. So to recap, very, very nice libraries enable you to build applications without focusing on the infrastructure. You focus on the actual problem space you're trying to tackle. And this comes from Microsoft infrastructure as well as from third-party infrastructure that they can leverage the uniform interface that we are exposing. Of course, sometimes the data you have is on-premises, or some of it is on-premises. So the nice thing about using the a standard interface to data is that now, regardless of whether you're consuming consumer or infrastructure services from the cloud, or you have some services on-premises, you can always use the same interface. When you're on-premises, you can use the data services framework to actually go create the server-side endpoints that look just like the endpoints I've been talking about and showing so far in this talk. So in summary, we think that service alignment and unification is very important. There is a lot of value in it. So we're making the first set of interfaces available. We are exposing Windows Live Spaces photos, and you saw the URLs there. Feel free to contact us for details. There's also information in the Windows Live sites, in the developer sites. We're also making available the application-based storage service, which is both an experimental interface with an experimental service behind it. The idea of that service is to allow users to have a chunk of data stored out there in the cloud that is bound to a particular application for each user. So different applications of the same user have different buckets for data that are isolated from each other. And all of this is protected by the same authorization scheme, which means if you control your data. If you want to revoke access, you revoke the access. You get to choose who gets access to your pieces of information and so on. And finally, we have also the SQL Server Data Services service out there that does sort of base level sort of storage out there like if you want to move from on-premises to an online service. And it doesn't have it today, but very soon we'll align this behind the Atom Pub interface as well. And all of this is sort of rounded up with a sort of integrated developer story that means once you get used to this, to the protocol, URLs, and APIs, if you don't want to go lower level, then you get to leverage these sort of frameworks and tools and keep dealing with all that. So these services are out there. As I said before, we're sharing this in a very early stage. What we want is to hear your thoughts, hear feedback, make sure what we're doing makes sense, it's an interesting application, and so on. So we're here to get feedback. There are blogs, forums, and a number of channels that you can use to give us feedback. And we'll be hanging out here for the rest of the conferences as well. There's a bunch of related talks I would highly recommend. All of these REST sessions are recorded, so even the ones that I already passed, you can go back and take a look. The two that didn't happen yet is the Microsoft Sync framework talk and FitSync talk that will talk about how to actually synchronize this data together, and also a talk about real-world applications of RESTful data services like that. They could be on premises, but you'd use the same APIs that we've been using so far, so it applies to the broader sense. And you'll see a drill down on many of my examples there, including third-party components. Yeah, I'm sure Mike have actually them running, so you'll actually see them going. So, with that, I wanted to, so I'm a little bit over time, but I'll be here for any questions that you may have. If not, we'll be around for the rest of the conference. It's almost done today, and I want to thank you very much for coming today.